Welcome back, everyone. This is Mr. Everett, and we are in Course 1, solving two-step inequalities. And it's very similar to our one-step inequalities, except we have two steps. So we're going to subtract 7 from both sides in this case. And then we have to apply the inverse operation to remove our coefficient. Let's get started. So in Unit 3, Course 1, we solve two-step equations. In the following lessons, we will find a solution set. Remember, an inequality has an infinite number of answers. So we'll go to example 1. Find a solution set, or find the solutions for 5 times some number c minus 5 is greater than or equal to 15, or at least 15. This means at least. And if you're wondering what this is, if you think about it, this is the p, this is the variable, and this is the constant. So all that really stands for is variable, coefficient, and constant. Okay? So we're going to solve inequalities that look like this. All right, so 2 steps. We're going to subtract 5 from both sides. Add 5 to both sides to cancel out the negative 5. We're left with 5c is greater than or equal to 20. Then we divide both sides by 5. C is at least 4. C is greater than or equal to 4. So what does that mean? Because it includes 4, we have to put a dot on 4, and then everything greater than 4. The next one looks the same, but it's a little different. We have a negative coefficient, and I hope you remember what that means. So we have negative 5 times some number c minus 5 is at least 15. We still add 5 to both sides. We're left with negative 5 times some number c is at least 20. But because we're dividing by a negative 5, we have to change the direction of our inequality. So that becomes c is less than or equal to negative 4. Again, because we're including negative 4, we use a dot. Sorry, my dot looks like that. And anything less than that or equal to negative 4. All right, so example 3. Now watch carefully on this one. This one tends to give people a hard time. 5 minus some number c is less than 15. Again, we have to get rid of the constant, or use the inverse operation to get rid of the constant. But keep in mind that this is like negative 1. What do you think the answer is? Okay, so we subtract 5 from both sides. Get rid of that. And we're left with the opposite of c is less than 10. Well, if that's like a negative 1, what will we have to do? We have to divide both sides by negative 1. And because we're dividing by a negative number, we have to switch the inequality. And again, 10 divided by a negative 1 is a negative 10. So be very careful. There is a coefficient there, and that coefficient is negative 1. So c is greater than negative 10. Because we're not including negative 10, we have to put a circle around the negative 10 and everything greater than. Okay, see if we can squeeze in one more. All right, so we have to be able to do this with integers, fractions, and decimals. So real quickly, we're going to add 1 and 2 tenths to both sides. Now be careful, we have a negative and a positive, so my answer has to be negative because I'm more negative, or the absolute value of negative 5 7/10 is greater than the absolute value of 1 2/10. If you remember from integers, same thing applies to decimals. So I have a negative 3 times some number x is less than or equal to negative 4 5/10. I'm dividing both sides by a negative number, which means that my sign has to switch. A negative divided by a negative is positive 1 5/10. 1 5/10 is about right there, halfway between 1 and 2. I'm at least that. All right, we're a little bit over 5 minutes, so we'll pause right here and come back, hopefully wrap this up.